Hi guys, in this video we are going to take a look at an example where you have to use the binomial probability formula. I'm not going to go into too much detail right now about how you know when to use that, but I will leave some links in the description if you need to brush up on techniques to help you identify if it's a binomial probability question or not. So for this question, we're just going to go through the mathematics, the calculations we have to do. So a recent study has shown that 70% of all adults between the ages of 18 and 21 are unaware of, I probably should say are unaware of U.S. taxation laws and regulations, and a random sample of 10 adults between the ages of 18 and 21 find the probability that at least 5 are unaware of U.S. taxation laws and regulations. So this is binomial probability. I kind of gave that away by telling you that in the intro. But just two little hints that told me that it was are one, why is there a purple line there? Fine, who cares? One, I have a sample. I've got a sample and I'm taking some from that sample. That usually means permutations or combinations. And then that percentage there, that 70%, also made me kind of think probably binomial probability. That's not like the end all be all definite 100%. If you see a percentage, it's definitely going to be binomial probability. But that helped me out there. And actually the other thing too was that there are really only two possible outcomes here. Either the, whoa, okay, we'll fix that. Hopefully. There we go, that's fixed and the purple line's gone. So as I was saying, there are only two possible outcomes. Either the adults in this age group are unaware of these US tax laws, or they are aware. There's no in between. Either you do know or you don't know. You can't have like a middle ground. So there's only two possibilities, and the bi of binomial means two. So that tells me binomial. Like I said, I'll leave some more resources in the description so you can brush up on the actual rules and how you can tell what kind of probability question it is. For now, we know that's what it is, and we are going to use the formula for binomial probability right here. Now, if you haven't already bookmarked or gone to the SSC's website, we do have a section just about statistics. This is where I'm at right now. You can hopefully see it on the screen. We've got the formulas, we've got the symbols, we've got StatCrunch tutorials, we have the tables that you're going to need later. Hint, hint, spoiler alert, whatever. And then we have everything broken down by chapter. Right now we're in chapter 3, for instance. We have some different printouts. We have the tech tutorials, so how you can use Excel or StatCrunch to calculate some common things. And then we have some more resources that go into more explanations about these different concepts you guys are learning. And we have these basically for every chapter. So right now I'm using the, where is it? The statistics formula by chapter, and that's where this is right here. So let me write this down on my whiteboard and we'll get into figuring out what each of these variables are, the n, the x, and the p and the q. So hang on a second while I write this down. Okay, so here's the formula written down. They basically just give it to you two different ways. This and this are just two different ways of writing the same thing. This part here, ncx, is the same as this here, the n factorial, n minus x factorial, x factorial. They are just two different ways of writing that we're going to be doing combinations. I will say that in some calculators and some programs, instead of an x, you see an r. So this could be an R, this could be an R, this could be an R. These could all be R's. And the reason I'm mentioning that is because we are going to be using the Desmos online scientific calculator. It is a completely free calculator. You're going to see me use it on a lot of videos if you haven't already. And I believe Desmos uses N and R instead of N and X. They mean the same thing. In both cases, N represents the total sample size, which for us looks like random sample of 10. So our sample is 10, so n is 10. And x or r, whichever one you want, I like r, I think because I learned that first, is the amount you're taking from that sample. Now this is an interesting question because this says at least 5. It doesn't say exactly 5, it says at least 5. And at least means it could be that number or higher. So I could actually use 5 or 6 or 7 or 8 or 9 or 10. I can't go above 10 though because my sample size is 10. R or X can never be bigger than N. It can be the same size or smaller, but it can't be bigger than that. So I actually have 1, 2, 3, 4, 5, 6 different possibilities for X or R. Which means I'm going to have to do 6 different calculations. If you see an at least or an at most problem, there's a good chance you have multiple calculations that you need to do. If this had said exactly 5, I would say x is 5, do my calculation, call it good, I'm done. But this is at least, so we're going to have a few extra steps. But I will start with just doing the 5. So that's my x, 5. Let's look at P. P stands for the probability of success, and in this case, it is 70%, which we need to put into a decimal, 0.70. And then we have Q, down a little bit. Q is equal to 1 minus P, which in our case is 1 minus 0.70, which is 0.30. So I think we have all of our variables. We have N, the sample size of 10. Our first X that we're going to use is 5. We have our probability, 70%. We have the complement of the probability, which is 30%. I think we have it all. So let's go ahead and plug it in. I'm going to plug it in into this version of the formula just so we can see how it looks all together. So n factorial. Let me use a different color for the actual calculation. This is a soothing blue. We could use soothing for math. So n factorial divided by n minus x factorial, and then it's multiplication between these different pieces. These are all being multiplied. The next part is the percentage of success, the probability of success, to the power of, oops. Did I say x or did I say 5? Because it should have been a 5. All right. So n factorial, there's our n minus x, okay, percentage to the power of x, which is 5 times, actually I'm not going to use times because that looks like an x, I'll just use my little dot there. So times the complement, and then n minus x. Whew. Okay, so that's what it looks like when I plug it in. I'm going to simplify the exponent here because the exponent is 10 minus 5. I can simplify that. 10 minus 5 is just 5. So there we go. So now if you wanted to calculate this by hand, first of all, why? No, actually, sometimes it is good to do these kind of calculations by hand, and we're going to do that together for this first one. And for future calculations, we're going to use Desmos. But first, let's start with doing by hand. So 10 factorial, that means 10 times 9 times 8, 7, all the way down to 1. You can see why when there are larger factorials, like if this was 23 factorial, it's not really something you want to do by hand, which is why you'll see the factorials built into a lot of calculators. Like I said, for this first one, we are going to do it by hand. We said that 10 minus 5 was just 5, so that becomes 5 factorial right here. So that's 5, 4, 3, 2, whoops. I'm using multiplication symbols here instead of little dots. Old habits die hard. And then there's another 5 factorial, so times 5, 4, 3, 2, 1. Okay, I'm going to do some canceling here before I even get on to these percentages, which I'm going to use a calculator for. Let me do some canceling. First of all, anytime you multiply something by 1, you're not changing it. So I'm ditching all of those times 1s. Goodbye. And I'm going to do some more canceling. I'm going to, let's see, there's a 5 here, and a 5 here, and a 4 here, and a 4 here. 3, 2. Okay, that's not too bad. I'm going to do a little more canceling actually because, and you can cancel a couple different ways. Let's see, 5 times 2 is 10, so I can ditch that along with the 5 and the 2. All right, so it would 9 times 8 times 7 times 6, and then I have 4 times 3. I could simplify a little further, the 6 and the 3 and the 4 and the 8. I think I'm going to call this good for now because I've already done a good amount of canceling. So I'm going to do 9 times 8 times 7 times 6. And I'm going to grab a calculator for that. And like I said, I'm going to be using Desmos. Now you can use just a regular phone calculator, but I don't recommend it personally. So 9 times 8 times 7 times 6, so 3024. And then 4 times 3 is 12. I'm going to go ahead and simplify that. If I take 3024 and I divide it by 12, I get 252. 252. Okay, so that's this whole thing. This whole thing works out to be 252. So what I'm going to do now, let's go back to my soothing blue. We have 252 possible ways to choose 5 from a group of 10, assuming order doesn't matter. That's what we've just done. This needs to be multiplied by the 70% to the power of 5, by the 30% to the power of 5. This is going to go into a calculator. I'm going to go back to Desmos over here. Let's click this out. 252 times 70%. I'm going to do the power of 5. And then to get out of the exponent, I'm going to use that right arrow key. And then times the 30% power 5. And there it is. My answer shows up right here. So what I've just calculated is the probability that if I have a sample of 10, the probability of choosing exactly 5 of those 10 in this particular problem where they don't know US tax laws, my probability is about 10%. I'm going to grab this whole number, the whole thing. It's not a whole number. I'm going to grab the whole number and I'm going to write that down. So 0.10 29193. 993. There's a couple more digits there. I'm going to grab 452. So like I said, if we had been asked what is the probability that exactly 5 of the 10 didn't know about these tax laws, I would do this and I'd be done. I'd be happy. I'd round this to 3 decimal places and it'd be great. Wonderful. Beautiful. But like I said, they said at least. At least means multiple calculations. So we calculated the probability that 5 out of the 10, but there's still the 6 or the 7 or the 8 or the 9 or even the 10 out of 10. So I have more calculations to go. This is just one of them. I will put it in a box because I'm going to need it for later. So what happens when you do at least or at most problems and you have multiple possibilities, usually you calculate each of them separately and then add them all up. Or in math, the word or usually means add. So that's what we're going to be doing. We're going to have several different additions to do. So I did that first one by hand, which was cool. For the next ones, I'm going to go ahead and set it up and then plop it into Desmos to save us a little bit of time. And I'm also going to make sure my accuracy is on point. So I like to do it by hand to get a feel for it. I encourage students to do that too so they know what's going on. And then after that, to save some time, I like to use a calculator. So this was 5. Let's go and do if it were 6. So we would do 10. And I'm going to use this other format here. I'm going to use this one now. Remember, n is the total sample size, x or r, whatever you want to call it, is the amount you're pulling from the sample, and our probabilities, q and p, are going to stay the same this whole way. It's just going to be the x that's changing for each one. So 10, this time we're choosing 6. Probability is still 70%, but it's 6 this time. And then we have 30%, and it's 10 minus 6. I'm going to do this, and I'm actually going to, while I'm here, set up the rest of them. So I have to go all the way up to 10 to account for the at least part. Dangnabbit, I made a mistake. Pro tip, don't rush. Okay, so let me check, make sure I'm out. So 10, 6, this is a 6, this is a 6, 7, 7, 7, 8, 8, 8, 9, 9, 9, flip my screen and have the formula or the expressions up here along with Desmos on the side so we can put them in and hopefully make this look decent. Okay, so here we are with the calculations we have to do. That last one we did is still here up on the screen, but I'm going to go ahead and clear that. And if you want to use Desmos to do combinations and do it a little bit faster than doing it by hand, then you can go to the function menu and you can choose NCR. This is why I told you that sometimes instead of an X, they use an R. A lot of calculators like Desmos or the TI-84 or the TI-83, they use R instead of X. So just, they're the same thing. So I'm going to check NCR, and it's going to ask me what my numbers are, and I'm going to work on this first row, 10C6. So back to main, N comes in first, which is 10, and then the second number, I have to do a comma, and then the 6, and then close parentheses. So this right here, NCR, parentheses, 10, comma, 6 parentheses, that's how you type this into Desmos. The rest you type in just like you would anything else. So times 70, okay, 70. This is the exponent key right here, a to the power of b. Our exponent is 6. And to get out of an exponent after you're done, just make sure you hit that right arrow key. Times, we got 30% exponent. And then our exponent is 10 minus 6. You can plug in a 4 if you want to instead, actually, because this is pretty easy to do. I'm going to do that. So 10 minus 6 is 4. And there's that probability. Let me write that down. 0.2001. Now, it may be tempting to round because you're going to get a lot of decimals, and most people don't care for that. I recommend not rounding until the end. Lots of times on homework, it's going to specifically tell you don't round until the end. And to be fair, sometimes if you do round, it's not actually going to change your answer, your final answer. But just to be on the safe side, unless the problem you're working on tells you you can round intermediate steps, I don't do it. So I'm going to write down all the numbers that I see. So those are all the numbers I saw for the first one. Let's move on to the next one. And here's another reason I like using Desmos. You do not have to type this all again. All you have to do is click or tap the number you want to change, delete it, change it to the next one. So I'm going to change the 6s into 7s. And then for here with the 10 minus 7 would be 3. So I'll change that into a 3. And there it is. 0.266827 wait, 932, yeah, okay. All right, I'm gonna go back at it. Now we're on to 8, so let's change, backspace, 8. This one would be an 8. Hey, 8. And then this should be a 2 next. For crying out loud, 2. All right, we get this one. 0.23347444405. Now you can probably see why I like doing it this way and not by hand. That first problem, I think, took us the same amount of time these past 3 did, if not more. This is saving us some time, and it also gives you a chance to see the question nice, neat, orderly, and make sure that the numbers are all correct, which is always good in math, to be honest. That's an 8. That's a headless 8. There we go. And then last one. Oh, I gotta stop pressing the wrong button. 10. And now this last one, if I did 10 minus 10, this would be 0. Technically, you could exclude this from your calculations. I'm not gonna, just for the sake of consistency, but it wouldn't matter if I... Actually, I'll show you. Because now I've said it, so I've got to show you. 2, 8, 2, 7, 5, 2, 4, 9. Anything to the power of 0 is just 1, so if you actually deleted that whole thing, you'd still get the same number. So, but for the sake of consistency, I liked it there. Okay, so we have them all. We have that first one we calculated by hand, this right up here, the 0.10291193. 2. That was the first one. And then we said that was a probability of exactly 5, but the problem said at least 5, which meant it could have been 5, 6, 7, 8, 9, or 10. And like I said, or usually means add, so I'm going to add up all of these ones together. So I will speed through that because you know how addition works probably, and we'll get our final answer in just a minute. Okay, so if we add all of them up, it looks like we get 0.95263, no, 2653012 Now that I've added them all up, I have all of my probabilities. Now I can round this. I'm going to round this to 3 decimal places. Your particular homework or quiz or test problem might ask you to round to something else, but I'm going to round this to 3 decimal places, and I'm going to get 0.953. So, given this question, and the information we were provided, the probability that at least 5 of the 10 in the sample are unaware of US tax laws is about 95%. That's pretty high. So anyway, this is how you can calculate the kind of binomial probability questions I showed you how to do it by hand, and also using Desmos. I will leave a link to Desmos in the description. It is completely free, no sign up, no download. It's a great resource, and like I said, I use it in most of my videos because it allows you to do pretty much everything you need to do nice and accurately. So that will be it for this video. I wish you luck, and if you have any questions, just let me know.